Welcome back to the channel, Bridging the Gap Student to Engineer, where today's video is going to be on nuclear engineering. So this is part of a new series of videos where we deep dive into various disciplines within engineering. So let's get started. So nuclear engineers, like all engineers, identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and math. We often think of nuclear as being applied to nuclear power generation or nuclear power plant, and that's absolutely a place where nuclear applies. But nuclear engineers and nuclear technology are in a number of different industries. 4 of them are listed here: medical, space, power, and defense. But there are others, and this is something that is growing, particularly when we talk about space exploration. We talk about going farther and farther into space, and other than solar or sun generated power, nuclear is really the only good way to get power to a spacecraft when it's gone for years and years and years. So there are a lot of different areas where this can apply. Nuclear engineers also research and regulate new uses and management of nuclear power and material. The keywords here are research and regulate. There are a number of nuclear engineers who are in research that are looking at new ways of applying nuclear technology and engineering to different applications, but also the regulation of that, the use of that power and that material. If you think about not wanting our adversaries to have nuclear materials, how do you regulate that? And are there ways of detecting others having nuclear material without us knowing? So there's a lot of defense applications for nuclear that are not necessarily just the ones that we think of that go boom. So lots of different ways that nuclear engineers get involved in making sure that the world is safe from the nuclear material that is out there. All right, so they also manage the release, control, and use of nuclear energy and nuclear waste disposal. There is some nuclear waste that is generated when we create nuclear energy, and so we have to figure out how we are going to manage that and provide for the safe disposal of that waste. And then nuclear engineers also monitor nuclear processes to ensure compliance with safety and environmental regulations. So we'll get into this when we talk about different organizations, but and we've mentioned it a little bit when we talk about foreign countries having nuclear material that maybe we don't want them to have. How do we monitor that, and how do we make sure that everything is safe and that we are not releasing nuclear material into the environment where we didn't mean for it to be? So lots of different areas that nuclear engineers get involved, but all of them in some way are related to the use of nuclear power, nuclear energy, nuclear materials. Okay, so let's look at the career outlook. So this, like all of the other deep dives we're doing into disciplines, comes from the Bureau of Labor Statistics. The source is on the bottom of the page, but the link is also in the description of this video. So take a look if you're interested. The median pay for nuclear engineers is one of the higher ones, at about $125,000 per year. This is not starting salary. This is for all engineers with that title that remain in nuclear engineering throughout their career. And then typical entry-level education is a bachelor's degree. This is pretty common across all of engineering disciplines. One of the reasons that makes engineering attractive to a lot of people is that you don't need an advanced degree to get into it. Now, the number of jobs, this is just in the US. In 2023, the Bureau of Labor Statistics says there's 13,400, and they are expecting a decline over the next 10 years. So I want to comment on this because, yes, this is the data that's published. Having worked in the nuclear industry and very close to the nuclear industry for a lot of years, I will tell you that it is an industry where a lot of people are retiring because the heyday of nuclear power and nuclear power plants, when there were a lot of people majoring in nuclear engineering, was a generation ago. And so the people who are working in the industry are near retirement, at retirement. So it is important that we have a lot of new people coming into the industry. Also, a decline in the number, just overall, indicates that there is an assumption that nuclear power plants will close or that the use of nuclear will be reduced in the world somehow. I find this a little bit odd that the US government is projecting this, because there is somewhat of a nuclear renaissance going on right now. Well, we've been talking nuclear renaissance for many years. And what happens is nuclear renaissance, and then there's, like a Fukushima or um, some activity or some event that causes concern and public concern for the safety of nuclear. And so that kind of goes up and down. But the things that I said in the beginning about nuclear being really important for defense and understanding who in the world, around the world, has nuclear material, what are they doing with it? Are they using it to build weapons, or are they using it for peaceful uses? All of those activities are things that we need nuclear engineers for. And so there is not a decline in that right now. If anything, there's more of a concern that some of the larger powers in the world, who we may or may not want to have nuclear weapons, um, we really need to have the technology to monitor all of that. And for that, we need nuclear engineers. So while this does look not very positive, I am going to show you, when we go through the student outcomes of the various universities, that the numbers and the placement numbers are not necessarily supporting um, a, um, a negative outlook that we're seeing here. So anyway, this is the data. I have a different perspective. And if you are interested in getting any more information or wanting to ask questions about it, please leave a comment and we'll get back to you. Okay, so industry organizations. We always do this with various engineering disciplines. I actually have two different slides on this because there are so many and there are different types of organizations. The American Nuclear Society and the Nuclear Energy Institute really are what you would consider the more general industry organizations. But there are a lot of other ones. There's institutes specifically for managing nuclear materials, Society for Nuclear Medicine and Molecular Imaging. So these are very specific to nuclear in um, in medicine and how we use nuclear in medicine. And then some of these other ones, we get into the international organizations. So the World Nuclear Association, Nuclear Threat Initiative, the Naval Submarine League is actually US, but pretty quickly, what you see in the nuclear industry, it is not a huge industry, and there are a lot of links across allied countries talking about nuclear um, as a whole, and how we use it in our society and all those sort of things. So, and actually, we'll get into that a little bit in the next slide. But if you are interested in maybe continuing to live in the US, but having a lot more outreach to other countries, nuclear is actually a pretty good way of doing that, because a lot of the nuclear work that we do is it is focused on the US, but we also have allies that are not necessarily as technologically advanced as us that we want to support them. And so we work with those allies a lot when it comes to nuclear. So the reason that we bring up industry organizations is because if you are interested in nuclear, as you will see in our video that talks about how to get a job or how to get scholarships, These industry organizations are really a good place to start when you're looking for support for you as you're going through your journey as a student. And they can provide mentorship. They can provide programs. Some of them have outreach programs. They can provide scholarships, all those sort of things. So definitely, if you're interested in nuclear, start looking at these. Starting with NAS and going to NEI, and then looking at some of the other ones if you are interested specifically in like nuclear for medicine or submarines or something. Definitely pull these up, look at them, see what opportunities they have. If you go to a school that doesn't have a student chapter, this is a really good opportunity for you to have some leadership and get involved in the industry. Okay, so government organizations. The last one, industry organizations, is government. The U.S. has the NRC, the Nuclear Regulatory Commission. This is where we talked about engineers doing some oversight and ensuring that the safety and environmental rules are followed. And then the Department of Energy. So Department of Energy has a wide scope, and that includes the nation's nuclear weapons stockpile and a lot of research that goes into monitoring other countries of the world's use of nuclear and how we can better use nuclear. So there's a lot of things that go on within the Department of Energy that are related to nuclear that might be interesting to you. So something to look into if you're interested. The International Atomic Energy Agency, IAEA, is an international body that brings a lot of countries together. And when we talk about oversight of countries that have known nuclear material and known uses of that, that a lot of that oversight comes from the IAEA. Okay, and then the Nuclear Energy Agency, and then also we start getting into international organizations, Brazilian-Argentine Agency and European Agency. And the reason for this is just like I said earlier, this is a pretty small industry, and it's not that, if you become a nuclear engineer, you're going to move to Brazil, but you might be working with them or somehow having engagement with them as you're working your job. Okay, so when we get into schools, some of the other majors we've looked at, like 170 ABET accredited programs, nuclear only has 22. So this is, like we've said before, it is a small industry. Your local state flagship might not have it. And so we'll get into some of those alternate majors you could do if you want to get into the nuclear industry, but don't necessarily have access to a nuclear program. But I'll provide the link to the ABET website where you can do a search for the nuclear majors and where those schools are. The nuclear industry is not necessarily one where a professional engineer license is required. And so getting a nuclear engineering degree, I'm not aware of any programs that are not ABET accredited, which is why I use the ABET accredited search, but wouldn't be too scared off if there are programs that are not ABET accredited. It's just a good way to get the list. So some of the sample programs are here, but we'll get into their outcomes. Okay, so like all of these videos, the schools where we provide information are the ones that share their information. They're not necessarily the best. They're not necessarily the cheapest. Those types of questions really are not something that I can just answer for everyone. I don't think that looking at rankings is really the best way to choose a school. So in this case, like in all cases, I'm going to give you the student outcomes for a sample of schools that provide a lot of information and give you some insight for that. So, all right, if we look at the number of grads for each of these schools, they're all pretty small. If you look at the percent of the total engineering school, All of them but University of Tennessee, Knoxville is 1%. If you go into nuclear engineering, you're not going to be in a class of 200 people. Even at Purdue, which is a huge school, and some of the other disciplines we see like 200 grads, they're small. They're just small. The annual grads here that have the greater than the number symbol is because the school lets you know how many people responded to their survey. And so the numbers here are the number who responded to the survey, not the actual grads, but it is representative of what is going on with the rest of them. Now, the percent of total engineering on UT Knoxville is the only one that's not 1%. It is 50 grads, which is big compared to all the other ones, but I will just talk about that for a little bit. So Knoxville, Tennessee, and specifically Oak Ridge, which is just north of Knoxville, is a really big area for nuclear. There is the Y12 site, that is a Department of Energy site. There is the Oak Ridge National Lab, which is also Department of Energy. There are a lot of people working in those places, a lot of research, not just into nuclear, but there's a big emphasis on nuclear there. So it is not surprising to me that UTK has a larger number of grads. When I first saw this, I thought maybe the labs were, paying for people to get their degree. But I did talk to someone a few days ago who went to UTK to get his nuclear while working at one of those places, and he said there's not very many. It's mostly just students right out of high school. So it sounds like it's a pretty similar program to a lot of other schools. But if you're interested in being in Eastern Tennessee, UTK is the place to go, and you can have an entire career in that area of the country without needing to worry about going anywhere else, because there are so many jobs in nuclear in that area. Okay, so let's go to percent grads positive outcomes. So this is the only discipline that I have researched so far that has so many 100% positive outcomes at so many schools. Even Berkeley, 75%. That's actually higher than their average for their engineering school. And with such a small number of grads reporting, it's really just saying that 2 people out of the 8 don't have a job. They're not continuing their education. They're still looking for something to do. So anyway, this percent is where I go back to the data from the Bureau of Labor Statistics and question if it does look like this is a declining industry, why is it that so many of the grads are in such high demand? That's the question I have. And being in the industry, I would say this nuclear engineering is a good thing to go into with opportunities for the future. Okay, and then we looked at percent grads employed. If you look at all these numbers, they're kind of low, and that indicates, you'll see when we look at percent grads continuing their education, some of that, the continuing education are still small, but for half of the grads in any engineering discipline to be going to grad school is pretty significant to me. So it is something where if you want to get into research, you might consider getting that advanced degree, and maybe you would want to get that advanced degree if you're going to be doing research. So when we talk about like national labs and getting into places where there is a lot of nuclear going on, UC Berkeley is near Lawrence Livermore National Lab, which is in Livermore, California. Purdue and University of Illinois Urbana-Champaign are somewhat close to Argonne National Lab. These are things that you can look up, and I'll provide a link to the national labs in the description. And then Georgia Tech is actually close to the Savannah River site. which is a Department of Energy site, and then UTK is near Oak Ridge National Lab and Y12, as I mentioned. So all of these schools that I happen to have on here are close to activities where there is a need for nuclear engineers. And anytime you can go to school close to where your job is in demand, you have a lot better opportunity to get a job and have relationships with those companies, get internships, all that sort of stuff. While I'm on the subject of national labs, one thing I have noticed is that Texas A&M, which is not on here because they don't provide good data, Texas A&M is a place where all of the national labs that I'm aware of recruit from. So that is something to look into if you're looking at nuclear and you're interested in the national laboratories, which are owned by the Department of Energy. Something to look into. Okay, so first employers, this is just giving you an indication of what type of jobs or what kind of companies grads go into. So Westinghouse, Dominion Energy, TVA, and yeah, just go with those three. Those first three are power generation. They own nuclear power plants, and they generate electricity with nuclear. A General Dynamics Electric Boat is a funny name for a submarine company that does work on nuclear submarines, but it's called Electric Boat. So I thought that was a little bit odd with that name, but something to look up if you're interested. BWXT actually has a presence at a lot of these various sites that are ran by the government, or owned by the government and run by managing and operating contractors. So they hire a lot of nuclear labs or nuclear engineers, excuse me. And then national labs. I've just listed three here because those are the ones that appeared on the schools that I'm looking at, but there is an entire network of them. And if you are interested in the national labs, again, I will provide a link in the comments. Okay, the US NRC, Nuclear Regulatory Commission, this is the government agency that oversees nuclear work and especially establishes guidance and rules and oversight for nuclear generation. And then the last one on here, Guidehouse, that is a consulting firm. And there is a little bit of an indication on the next slide where we talk about first job titles. There is a consultant job title on here that goes with the Guidehouse, I believe. So if you're looking at first job titles, and if we are looking at a lot of those engineers going into power generation, being a reactor engineer, reliability engineer makes sense with those two. But also being a project engineer, which is really about doing the design side of projects, and that is going to be in a lot of different industries with a lot of different majors. Nuclear engineer, having a title that goes with your degree is a nice thing to have because you're right in line with what you've been studying. And then I'll just skip the consultant one and go to chemical and radiation safety officer. Radiation is a part of nuclear. And so having someone go into a role where they are a safety officer related to chemical and radiation makes a lot of sense. One thing I want to note about all of these is that all of them are directly tied to the discipline and to the scope that you'd be studying if you were a nuclear engineering major. The reason that is significant is because there are majors, mostly outside of engineering, but sometimes within engineering, where the first job titles don't really line up, and then you just question whether or not there really is a demand for that degree in the industry. So these job titles being in alignment really says that if you get a nuclear engineering degree, you will become a nuclear engineer doing something very closely related. Okay, so on a couple of these discipline deep dives, we have alternative majors, and this is really, if you want to go into the nuclear industry, if you're interested in it, but you don't have an opportunity to major in it for whatever reason. I mentioned that nuclear engineering is not at all of the state flagship schools or even the state schools that might be near your house. So this is just some options that will allow you to get into the industry without being the person who is the expert on nuclear itself. So electrical, mechanical, chemical, computer engineering management, engineering physics, all of these majors are things that could get you into that industry and could get you working with nuclear engineers. All right, so resources. I try to give you resources that I can find to either get more information or have experiences related to the discipline. In this case, the European Nuclear Society has a really good website called Nuclear Basics. So that link is in the description for this video. And then also Purdue University has a summer program for rising seniors called Atoms at Work. If you are interested in nuclear and you are going to be a senior or not yet a senior in high school, this is something to look into to see if you can get into the program. Even if you don't think you can afford something like that, I would really encourage you to look into it and see if you can get scholarships. That's a really important way for you to get exposure to things. And usually these types of programs, especially sponsored by universities, want everyone to have access to the program and have scholarships available. All right, well, that is the end of our deep dive into nuclear engineering. I hope that it was helpful, informative, and intriguing. If you have any questions, please leave them in the comments. We'll get back to you. If you would like more information about anything you've seen here, I will be providing the links in the description of the video. So click on those to do a little bit more research or ask a question and we will get back to you. So thanks for listening to the end, and we will see you on the next one.